So now we can mess with the actual navigation itself. One small step before that, we need to add a collider onto the skeleton, so that way he doesn't just fall through the floor. So the plane, if we actually look at any of the planes, you see they come with a mesh collider. But that on its own doesn't do anything because the skeleton needs to also have a collider, so that way it can detect if it's colliding things. We can just add something like let's do a capsule collider. In on him. You can see it's pretty small. It's actually hard to see here, but it's this kind of small green circle on the ground. I'm going to set it to be 0, 1, 0, with radius 0.5 and height 2.2. You can see that kind of takes over the height of the skeleton, goes a little bit underneath, sort of, and extends beneath, but kind of keeps it so he'll just stay right above the ground. Now to do the actual navigation, we can go to the window panel again, and do Window, AI, Navigation. That will make a new tab appear next to the inspector. And there's a couple tabs within that here. So the Agents tab here allows us to set settings for the size of our agent, as far as width and height and all that. What kind of slopes can they stand on? So you can see if you adjust the max slope. That would allow if you have ramps or something like that in your engine. This would allow it to determine what's the steepest it can climb. Which is really convenient. I've seen debug rooms in games before, in like prototype areas, where you can see the numbers laid out like directly in front of a plane to show what angle it's at, so that way you can do this sort of testing. You can do that on a per agent basis, where we can have a humanoid agent, we could have a bunch of other custom ones. I haven't messed with it all that much before, but usually basic is enough for things. The Areas tab allows us to set custom areas, so that way we can define specific properties that we can apply to objects, and that would allow us to separate between what type of agents can do what things on what type of objects. We're not going to mess with that here. I'm going to skip on the bake for a second. Fourth tab, Object, allows us to filter things in the hierarchy based on different properties, like things that are mesh renderers, or things that have terrains built in. And then within that, we can set properties for each. So that way we can tick off all items that are a certain type. These can all be navigated together. We can do that kind of filtering. The actual Bake tab is where we actually create the NavMesh. So if you click it now, you'll see it does nothing. Click Bake, nothing changes. There's no visual indication that anything happened. That's because we haven't told Unity at all what kind of things can be walked on right now. Right now, this is just a basic default navigation tab with nothing going on in it. So the way we can do this is, there's actually a couple ways. There's a lot of more slightly tedious ways. I find this to be a little easier. This is a relatively new method that I didn't know about until now. But if we go to the hierarchy here, we can search up in that top area for cube. Because we named all these cubes, all of the cubes that are each of the 4 corners of each of the 9 rooms, so that's like 36-ish cubes, I think, those all show up in the list here. We could now do the same kind of shift-click on all of these, and select all of them. Go over to the Object tab. We can click Navigation Static. The word static is one of those types of words that I feel like nobody understands what it means in programming, even the people who know what they're doing. In some languages like Java, static refers to objects and whether a method belongs to an actual object or the class as a whole. It can mean a lot of things in different contexts. Here, especially in Unity, it has a lot to do with whether an object is moving or not, more often than not. So I've ran into bugs before where an object won't move the way it's supposed to by a script because it's set to static, which overrides it. My understanding here is this is a specific type of static that is within the context of navigation, which is basically saying that this item is not going to be moved, and it cannot be moved, and it cannot be interacted with, so avoid it. That's my grasping of it. That seems to be more or less accurate to what actually happens. So, if you do that, we can now do that. I'm going to save to be safe. And we can click each individual cube and make sure that that actually saved, that all 36 of them have that checkbox enabled. That looks good. And we're going to do the exact same thing for the planes as well. So if we search for plane, we want all 9 of those to also be walkable. Now, because the plane is underneath the skeleton, it's walkable. The cubes are next to them, they're too high up to step on, so they get avoided that way. Cancel out of that search as well. And now if we click bake again, we'll get different results. You see, now we get the little blue terrain that I mentioned earlier, where the blue area is representing this is an area the agent can walk on. The white areas are not. You can see that extends through pretty much all of the plane, and just because of the filtering we did, it automatically detects those cubes are bad. Do not touch them. Feel free to mess with these settings a bit. If you change, for example, the agent radius to be thinner, you can maybe guess what that might mean. If the agent is thinner, that means they can get closer to items before they get actually bumping into them. So if we rebake with the agent radius set to 0.4, see, it actually looks kind of weird, but what results in that is that we can get closer to the cubes. And in fact, I think when I tried this earlier, they got almost too close, to the point where the skeleton kind of morphed inside of it a little bit. 0.5 seems to be a sweet spot. But if we put it back to 0.6 now and go upwards, you'll see the blue area actually shrinks a bit. That's because the agent is taking up more space now while walking around, which means it can't get quite as close. In fact, barely any space at all. Put that back to 0.5, leave it as is. Nothing else needs to be changed for now. We're not doing any stepping, we're not doing any height-related things. These are just cubes that are high up. If the cubes were closer to the ground, you could set certain ones at certain heights, and then you could certainly tell the NavMesh to step on, things that are a little bit higher and not too higher. You can have some fun with that, But now, to actually have this be usable in the scripting, we need to add a NavMesh agent to the skeleton. We had the actual NavMesh set up, but we need the ability to tell the skeleton, you are going to follow this path. We add a component, NavMesh agent. We leave all of that by default. You can mess with a couple things later, I'll point out, but for now it's all fine as default. Now we can tab back over to the script. We can add a public variable for that. Add a public NavMesh agent. Agent. You notice that it's kind of underlining here. I'm not sure if this is a Visual Studio thing. That might be just it's not auto-recommending, but you do have to manually put Unity Engine.ai. So that way we bring that class into the scope of the project. While we're here, we're going to add two things that we'll use a little bit later. We're going to add a public transform array called points. We'll also add a private int point count. The idea behind this line is that we're going to have an array of different transforms. Again, each transform is just a set of positions, scales, and rotations. But we'll have a list of effectively 9 objects and what their location is in the environment. And that's going to be the thing I mentioned earlier, where you can pick one of those at random every time a certain thing happens. And then we'll use that to determine what the next destination for the NavMesh agent would be.